All right, hopefully this will give you some concrete things to go for in terms of how can you test something for convergence and divergence. We're going to talk about 4 of them, 4 different tests. One you actually already know. All right, the first one is a convergence test for a geometric series. This is the one you already know. What makes something a geometric series? Okay, all right, and we usually call that multiplier what letter? Okay, so if the geometric series has a multiplier, so assuming a geometric series has R, okay, and what have we talked about that R, it needs to be constrained by or limited to? Okay, so it needs to be that the absolute value of the R has to be less than 1, which is another way of saying -1 is less than R, which is less than 1. So in other words, if the multiplier is between 1 and -1, then, assuming that is true, then the series will converge. You already know that one. In fact, it will converge specifically to the value a sub 1 over 1 minus r. So we have already learned that convergence test. So if you're looking at a series and they say, is it convergent or divergent, and you recognize it's geometric, and you recognize that the multiplier has an absolute value that's less than 1, you can say, yes, it will converge because it's a geometric series with a ratio or a multiplier that's between -1 and 1. That one we already know. I'm going to give you 3 more of those such tests. The next one is a test for divergence. All right, the divergence test for the nth term. This is why I had you practicing the limit as n approaches infinity last night in your quick review homework. All right, this divergence test is based on the limit as n approaches infinity of a sub n, and we'll call that L. If L is not 0, so if that limit is anything other than 0, positive, negative, big, small, it doesn't matter. If that limit is not 0, then the series will diverge. So this is only a test for divergence. Logically, that should make sense. If the last term, if you are adding on numbers that aren't 0, then this is not going to converge to anything. It's just going to keep growing and changing and diverging because you're not adding something that's 0. So if the limit at last term is not 0, it's going to diverge. If the limit is 0, the test is inconclusive. It's not enough, so the converse is not true. You can't just say if the limit is 0, then it's going to converge. That there's not enough evidence to say that. You just say, I can't conclude either way what's going to happen with this particular test. So then you'd have to move on to a different test. So this is one to try. If you're testing for divergence, check the limit of the last term, or as n approaches infinity. So then we need something that can help us if the limit is 0. So we're going to move on to another test. You know what, actually, let's do a couple tests on, let's do a couple examples on this one before we move on. All right, so maybe it'll just say something like determine the convergence or divergence if possible. All right, so our first example is going to be looking at the sigma of 3 to the n over n plus 2 as n goes from 0 to infinity. Will this converge or diverge? We're going to use the test to talk about, we'll check its divergence. So we want to take the limit as n approaches infinity of that nth term, so 3 to the n over n plus 2. So if we plug infinity directly into that limit, what will we get? I'll get 3 to the infinity over infinity plus 2, which is infinity over infinity, which is an indeterminate form. So I'll need to employ L'Hopital to help me out. So the derivative of 3 to the n is still 3 to the n times the natural log of 3 divided by the derivative of the bottom, which is 1. And I'll plug infinity into that. So I'll get 3 to the infinity times the natural log of 3 over 1. And what does that turn out to be? Infinity, which is not 0. So because the nth term, which is the last term if we could get to 1 in an infinite sequence, because it's not 0, in fact it's infinity, then the nth term test tells us, since this is non-zero, it's not 0, then this will diverge. So this series, 3 to the n over n plus 2, diverges. Because the limit of the last term was not 0. So you can conclude, this is a test for divergence only. It will diverge if the limit is a non-zero value. Okay, another one. So this one we're going to go from 0 to infinity again. This series is defined as 2n over n squared plus 3. And we want to test to see if this will diverge. So I'll take the limit as n approaches infinity of 2n, not 2 to the n, but 2n over n squared plus 3. Again, plugging infinity into here, well, I'll get 2 times infinity over infinity squared plus 3. That's indeterminate, so I'll need L'Hopital once more. I feel like that looks like an H. Okay, all right, so then the derivative of 2n, okay, 2 over 2n, which reduced is 1 over n, which when I substitute is 1 over infinity, which when I evaluate is 0. So this limit did come out to be 0. So what's the only safe conclusion here? It's inconclusive. All right, we cannot determine either divergence or convergence. So then we're going to need another test to help us out. If you can't determine either of it, if it's inconclusive, then we'll need another test so that we can draw a conclusion. So this leads us to our third test. All right, so we have the convergence test for geometric series, the divergence test on the nth term. And then our third one is called the ratio test. And this can tell us both convergence and divergence, which is really helpful because it can do two at the same time. All right, this works, so it's like, why wouldn't you use this all the time? Well, because the nth term test is really easy if you're just if you can get it to be not zero, it's actually the easiest one to do. But if you need to test for convergence, then this ratio test is great. This works really well. This is ideal for factorials and exponentials. Not saying it doesn't work for the other ones, but it definitely lends itself to these types of functions best. Okay, to do this one, you take the limit of the ratio of any two successive terms in a row. So you're going to pick an arbitrary term. So if I say go to the kth term, then what term would be the successive term that comes after it? The k plus 1. Okay, you want to find the ratio of those two things. And the second one always goes on top. So we're going to find the limit as n approaches infinity of a sub n plus 1 over a sub n. So this is stacking, or it's a ratio of two consecutive terms. And that's going to equal L. And then you analyze what L means. If L is greater than 1, the series will diverge. Let's see if that makes sense to us. If L is greater than 1, what does that mean in the relationship between the size of the two successive terms? Which one's bigger? The second one is bigger, which means, okay, then if I looked at the third one, it would be bigger still. And so all the terms are getting bigger, so it's going to diverge. Okay, so hopefully logically that makes sense to us. If L is less than 1, that means that the second term was smaller, which means the term after that would be smaller. Okay, and so then we can conclude the series will converge. So what's the only other option? If L equals 1. The test is inconclusive. Which which is why we're going to need a fourth test, which is all. They're done. Okay, so let's practice these a couple times. So a common question is like, how do I know which one to use, which test to start with? My answer is kind of like, well, how did you know what U substitution to pick? It came from practice, right? You had to kind of practice, and then you kind of got good at knowing what U substitution was going to work best here. All right, in the same way for doing tests like these, okay, if it's got a factorial or an exponential in it, go to the ratio test right away. That one's going to be good. If it's doesn't have one of those, try the nth term test first. Or if it's geometric, for sure do that one first. So they kind of lend themselves well to certain things, so know what to look for. Okay, again, determine divergence or convergence. All right, so I guess this is technically example C. The sigma, as n goes from 0 to infinity, of the function 3 to the n over 5 to the n plus 1. I've got two exponentials here, so this is going to be set up really well for the ratio test. So we want to do, now if you don't like n, if you'd rather use k, k works too if it bothers you. Okay, but the ratio test says to take the n plus 1 term divided by the n term. So for me, the n plus 1 term would be 3 to the n plus 1 over 5 to the n plus 1 plus 1 divided by the original n term, which is 3 to the n over 5 to the n plus 1. Now that's awkward to write it like that. So you're going to probably find it easier to write it like this. 3 to the n plus 1 over 5 to the n plus 1 plus 1, and then multiply by the reciprocal instead. So then 5 to the n plus 1 over 3 to the n. It's probably going to be easier to write it like that. Now something there can be reduced. Okay? Oh, all right, go ahead, Blake.
You're going to do infinity, it's just the n plus 1 is just going to get rid of n. So for each case.
Yeah, these for sure can be reduced. Okay, because 3 to the n plus 1 over 3 to the n just leaves you with, what's the only difference between those two? 3, okay. So the limit as n approaches infinity of 3, and then we're left with 5 to the n plus 1 over 5 to the n plus 1 plus 1. Okay, if I plug in infinity into both of those, what will I get? I will get infinity over infinity. I'll get 3 to the 5 to the infinity plus 1 over 5 to the infinity plus 1 plus 1. That's infinity over infinity, so I'm going to need L'Hopital. Now, the number 3 is a constant, so I can pull the number 3 out in front of the limit because it is a constant, and I'll use L'Hopital now. So the derivative of 5 to the n plus 1 is 5 to the n times ln 5. And the derivative of 5 to the n plus 1 is 5 to the n plus 1 also times ln 5. So now I can reduce those. The ln 5's reduce, and what happens to the 5 to the n on top and the 5 to the n plus 1 on the bottom? I get 1/5. So I'm left with 3 times the limit as n approaches infinity times 1/5, which is 3/5, which is ultimately less than 1. So my result was less than 1. And when the result is less than 1, I can claim that the series will converge. With confidence, according to the ratio test. Okay, any questions on that one? Boy? No, okay. All right, we've got time for hopefully this one. I don't know if we're going to get to the 4th test or not, and that's fine if we don't. All right, n equals 0 to infinity of 3 to the n over n plus 2. So we'll take the limit as n approaches infinity because it has a exponential in it. So I'm going to do 3 to the n plus 1 over n plus 1 plus 2 over 3 to the n over n plus 2. So again, you have that situation where it's awkward to write it like that. So it's easier to multiply it by the reciprocal. So 3 to the n plus 1 over n plus 3 times the reciprocal of n plus 2 over 3 to the n. And then we've got another opportunity to reduce the 3's here. And so what constant can I pull out to the front? 3 times the limit, and I'm left with n plus 2 over n plus 3. What will the limit of that be? Well, it's going to be infinity over infinity. Okay, so then I do L'Hopital, and then what will the limit be?
1.
Okay, so this is going to turn out to be 3, which is greater than 1, which is not inconclusive. The only time it's inconclusive is if it's equal to 1. Okay, this means we have a divergent series.